In this session, I am going to take arrays. Here you can see what is an array, why array is used instead of variables. That means why array is powerful than variable, how array is being declared in any programming language, how you are going to initialize values into an array, and how memory allocations are actually happening inside the array, and how you are going to read array elements into an array, and how to print elements from an array. So these are the things I am going to discuss in this session. So let us start with an array. So what is an array? So this array is a derived data type. I trust that you know what is a primitive data type. Primitive data type examples are int, char, float, etc. And this array is said to be as a derived data type. So before moving into the array, let us take a small example and mention about a variable. So when you are going to declare a variable, how you are going to write? Suppose you are going to declare a variable which is of integer data type, int a. This is the way you are going to declare a variable in C programming language. So what is actually happening when this statement is executed by the compiler, the memory manager is going to allocate a memory location for this variable a, and that location is symbolized with the term, with the word or letter a. So it will be, this can be represented like this. Okay, this memory location is initialized, allocated by the memory manager to A. And each memory location is having memory addresses. So suppose the address of this memory location is 2000. Okay. All these addresses are mentioned or represented in hexadecimal format. Okay. But for the simplicity purpose, I am using the integer values here. So suppose the memory allocation is done at 2000 memory address, and that location is given to this variable a. Now in the next sentence, where suppose when you are writing this a is equals to 10, you are assigning the value 10 to this a. What is actually happening? This value 10 is assigned to a. That means you are going to store the value 10 inside the memory location symbolized by a. Okay, so this is the representation of this statement. The value 10 is stored inside the memory location symbolized by the word a, symbolized by the variable a. Okay, so now next statement, suppose you are going to assign 20 to this variable a. Is it possible to assign 20 to this variable a? Yes, it is possible to assign 20 to this variable a, but the thing is that, but the main drawback here comes that you are not going to store 20 with this 10. This 10 will be overwritten. This 10 will be overwritten and 20 will be stored here. So instead of 10, you will find 20. New value come. And when you want to store another variable value here, suppose the next statement is a is equals to 30. So again, this 20 will be eliminated from this a and 30 will be stored here. So that means at a time you can store only one value inside a variable. At a time, a variable can hold only one value. So that is the main drawback of a variable. So when you suppose you want to store 5 values, 5 subject marks of a student. So you are going to use 5 different variables for holding the subject marks of a student. 5 subject marks of a student. And suppose think of a situation when you have 100 employees in your organization and you are supposed to store the phone numbers of 100 employees. Then with this array, what you can do only, you have to use 100 different variables to store phone numbers of individual employee. So that is a complex thing and that is impossible in case of a programming language. So because of this drawback of a variable, we are going for an array concept. Okay, so this array is a derived data type and it is going to allocate, the array is going to allocate large number of elements in a continuous memory blocks, in a continuous memory cells. Okay, and it is allocating homogeneous elements in an array. So when array is a data type, when the data type of array is integer, it is going to hold all the values which comes under integer. And when the array is of floating type, that means it is going to hold elements which are of floating type. Okay, so the declaration of array is this way. So this is your declaration. Int, suppose you are declaring an array with integer data type. Your array name is A, and your size of array, you have to provide the size of array also. When you are writing this statement, what happens? It is going to allocate, memory manager is going to allocate a memory block of 5 memory cells. Okay, and the indexes of 5 memory cells is starting from 0. So 0, 1, 2, 3 and 4. So this is how this statement when executes gets represented. So this variable A is holding the base address of this memory block. Suppose the base address is 100. So what is it holding? It is holding 100. So this array variable is acting as an internal pointer variable. Okay, so it is pointing to the base address of the memory block which is allocated by the memory manager when you are declaring an array. So what is the difference between the declaration of an integer of a variable and array? You can see the difference is that you have to provide the size with your variable, with your identity. So what is the syntax? You have to specify the data type of your array and the variable or identity with the size. This is the syntax for an array declaration. Okay, so let us see what is happening internally, how memory allocation is actually happens inside the computer system. So now you have to think about what is the size of the integer data type, how much space this integer data type requires. So in the traditional cases, this processor was 16-bit processor. So normally that time an integer data type is going to hold, it requires 2 bytes of memory spaces. But in the latest processors, what is happening? It is a 32-bit processor or you will find 64-bit processor. So this integer data type requires 4 bytes of memory spaces. So it depends upon the processor that you are using. So normally in today's world, the integer data type is needs only 4 bytes of memory spaces. Suppose your array, you have declared an array like this. This is the array. This is an array int A of 5. And when you want to assign values into this array, you have to use a curly brackets. This is the way you have to assign values. Suppose I am assigning 5, 4, 3, 2, 1. These 5 values are assigned inside this array A. So how it is going to represent, how this is represented inside? So a block of memory is allocated to this array, and this 5, 4, 3, 2, 1 is represented in this array A. Okay, and this is the array indexes 0, 1, 2, 3, 4. Hope this is clear to all of you. This variable is holding the base address of this block of cells. Suppose the base address is 100. So this will be holding 100 here. Okay. And I told you that each integer element is require 4 bytes of memory space. So the starting address of element which is present in the first index is 100. Then what will be the starting address of the second element which is present in the second index? That is index number 1. So what will be the starting address? It is 104. And what will be the next? It will be 108. This will be 112 and this will be 116. So that means for storing 5 values in the array A, you require 20 bytes of memory spaces. Why? Because each element requires 4 bytes of memory spaces and you have 5 different elements. So 5 into 4, 20 bytes of memory spaces are needed. So let us see, let us elaborate this example. Suppose we have this is a memory cells that are present here. Okay, these are the cells of a memory, and lot of memory cells are available here and here also. Okay, suppose this is the address which is for this memory cell, and this is for 101, this is 102, this is 103, 104, 105, 106, this is 17, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117 and 118, and this is 119. Okay, so the first element, what is the first element here? It is a 5. So how much space is required by 5? The element 5, the integer value 5 requires 4 bytes of memory. 1 byte is equal to 8 bits. So how many bits this value 5 requires? The integer value 5 requires 4 into 8 bits. That means 32 bits. Okay, so byte is when 4 byte is when converted into in terms of bits, it is 32 bits. So 32 bits are needed to represent the value 5. So this 5 is not written here like this. Okay, you have to, this 5 is internally converted into the binary representation. The decimal 5 is represented in the binary format. So the when you are going to represent the numeral value 5 in 32 bits, what you have to do? You have to give 29 zeros like this, 29 zeros prior to 101. Okay, to whole total this is 32 bits. All these are zeros. This is 32 bit. Okay, so this 32 bit space is needed here, and each memory location is of 4 bytes. This is of 4 bytes. So this 4 bytes is needed to store the value 5. This 4 bytes is needed to store the value 4. And this 4 byte is needed to store the value 3. This 4 byte is needed to store the value 2, and this is needed to store the value 1. Okay. Now let us elaborate this figure for one cell. So I told you this 5 is represented in 32 bits. So how this 5 is represented? So this 5 when is elaborated, it is of suppose this is the cell, 32 bits are there. Okay. 32 bits. That means 0 to what will be the index? 31. Okay, 31. And the value, the binary representation of 5 will be stored here, and 29 zeros with 101. Okay, so last it will contain 10. This is, and all these will be occupied by zeros. These are 32 bits. These are 32 bit, and the value it is 5. So likewise for 4, 32 bits will be there, for 3 32 bits will be there, for 2 32 bits, and 1 32 bits likewise. So how many total bits? Total bytes needed to store 5, 4, 3, 2, 1 are 20 bytes. Then how many bits require? When you are converting this byte into bits, that is 1 byte is equals to 8 bits, then 20 bytes is equal to 20 into 8, 160 bits you need to hold the values 5, 4, 3, 2, 1 in the integer array A. Hope this is clear to all of you. Now let us see how this array is declared locally and how this array is declared globally. Array can be declared in two different ways. Local declaration is there and global declaration is there. So let us see the local declaration. So this is the local declaration. Local declaration. Okay. So when you are declaring array int A of 5. Okay. So what happens? Local declaration means when you are declaring an array inside a method, inside a function, that is local declaration. And global declaration means when you are declaring an array outside a method, outside a function, that is global declaration. So when you are declaring an array inside a function like this, int A of 5, the size of array is 5, then it is going to allocate 5 different cells for this array. Continuous 5 block, a block of 5 cells for this array A. And do you know, when you are not initializing anything into this array during the compile time, what happens? The value inside the cells will be garbage value. It is going to hold garbage values automatically. Okay, that means when you are not initializing anything, then these 5 cells will be holding garbage values. This is garbage value. Okay, this is your array A, starting index is 0, likewise. So hope this is clear to all of you. And when you are going to initialize your array with values, suppose you are initializing array of 5 and you are giving 5, 4, 3, 2, 1, and then the representation will be like this. The 5 cells will be holding the 5 values. 5, 4, 3, 2, 1. Okay. So this is the representation of this statement. And suppose you are not giving all the statements, all the values to all the cells. Suppose you are initializing like this. 5, 4 only. Your array size is 5 and you are initializing only, you are providing only 2 values to your array A. So how this representation happens? This is going to give you 5 blocks, 5 cells. A block of 5 cells will be allocated and the first cell will be allocated with 5 value. The second cell will be given the value 4 and the rest of the cells will be holding the value zeros. Okay, so in case of the local declaration, when you are not giving the total number of values initialized is less than the size of the array, then rest of the cells will be holding 0 values. Okay, so these are the 3 different ways how you are declaring an array locally. Now let us see what happens when you are declaring an array globally. In case of the global declaration. Global declaration means when the array is declared outside the function, when the array is declared outside a method. So when you are writing integer of 5, this is the global declaration. So what happens? A block of 5 continuous memory locations are allocated to array variable A, and all the since you didn't initialize anything in the compile time, so values which are stored in the array will be 0. It is not garbage value. Okay, it will be holding 0. So this is the difference between local declaration and global declaration. Now let us see how you are going to access, how you are going to read the values into array cells. How you want to store, how you are going to store values into an array cell. Okay. So you know that for getting the value, for getting input from the console, you are using scanf function in C. So when you want to get one value from the console, you are going to write one scanf statement. Okay. And when you want to get 2 values, you will be writing 2 scanf functions. It is okay. When you need 5 different values from the cell, from the console, you will be writing 5 different scanf statements. It is okay. But suppose you need 100 different values from the user. So you are going to give 100 different scanf functions? No. So you are not. You are not supposed to use 100 different scanf functions in your programming. Okay. It is a complex task. So what you have to do when you need different values from your user, you have to iterate this scanf statement inside some loop. So some iterative processes, some iterative loops you have to use inside the programming. So let us see how you are going to take 5 values from the user. So suppose you have an array with you and you have declared your array, int is there, and you declare the size of array is 5. Okay, so that means you need 5 values. You have to store 5 values to the allocated memory cells. So for that purpose, I am here using for loop. So for I is equals to 0, I should be less than what, how many times this for loop should execute? This for loop should execute so that it will traverse the last index of the array also. Then only it should exit from the loop. So what should be the condition? Your I should be less than 5. Okay. Our index is starting from 0. So the last 5th index is 4. Okay. So what should you have to write here? You have to write 5 here. So I should be less than 5 and I plus plus. Okay. You have to in access the, you have to get the element into corresponding continuous cells. So you have to increment the I value also. For that purpose, you have written I plus plus. So now here you have to write the scanf function. Scanf, since you are getting one element from the console, you have to use a %d for one time. Okay. And now for what is the next thing? You have to mention the array name. Array is A, and you have to mention the which an index you are going to enter the value that you are getting from the console, on which index you are going to hold that value. This value is written, so that index you have to mention here. And then you have to mention where, you have to state the address of the memory location where you are going to place this element into the array. So this statement is going to give you 5 cells this way, and the index is 1, 2, 0, 1, 2, 3, 4, and this is array A. Okay. So let us see. So when this program is starting, when this program is executed, what happens? I am not going to write all other formats of this program. Just think about this logic part. So when this statement is executed, what happens? For I is equals to 0. What is the initial value? This I is acting as a counter variable, and it is going to hold the values of indexes. Okay. So this I is first pointing to, I is 0 right now, and 0 is less than 5. The condition is true. So it is entering into the for loop, and the scanf function executes. So when the scanf function executes, what happens? This ampersand A of I, what it indicates? It is telling that you take the value from console and put it into the memory location at 0, which is indicated by A of I. Okay, which is indicated by the ith memory location. So suppose the memory location is the 100 here, and this will be 104, this will be 108, this will be 112, this will be 116. So A of I value is 0 here. So ampersand A of I is going to give you 100. When I is equals to 0, it is going to give you memory location 100. Okay, so in that 100 memory location, you have to put the value which you get from the console. So you suppose the user entered 10, so this 10 will come here. And it is the next statement, it is iterating the for loop and incrementing the value of I. So I became 1 here. When I becomes 1, what happens? It is indicating to 104. So take the value from the console and store into the memory location 104. Suppose the user provided the value 20. So this 20 comes here. Likewise, I iterated, 2 happens and it is indicating to the 108 location. Take the value from the console and store the value at the memory location 108. So that is what happened here. Suppose the user has given 30 this time. So this is how this reading operation happens inside the array. You have to give this ampersand symbol with the scanf statement. Okay, inside the scanf statement. So this is what happens. So you must understand that these are the numeral addresses that I have taken to make you clear about the memory allocations. Actually, hexadecimal values are used for representing memory locations. Okay. So now let us see how you are going to print the elements from which are already stored in the array. So for printing the statement, what you have to do, suppose you have an array, int A of 5 is there, and all the values inside the array is this. Okay, A 40 is there and here 50 is there. So for printing the element from the array on the console, what you have to do? You have to use the printf statement. When you want to print only one statement, you can write printf statement once. When you want to print 10 statement, you can write 10 statements, but that is not a good way of writing a programming. And when you want to print 100 data which is already present in the array on the console, you are supposed to write 100 printf statements. No, that is a complex thing. Here also you have to use iterations. So here I am going to take for loop, and for printing the value, what you are using? You are using printf statement. So printf is there, and what you are supposed to do? What you have to do here? the value is the value, suppose you are writing like this, the value is and what is the value, and from where what you have to write here. Suppose the statement that should appear on the screen is the value is. So the value is this percentage D will contain that value, which is present where? Which is present in array's ith indection. Okay, array is ith indection. So that has to be represented by A of I. Here you don't have to represent ampersand. Why? Because when you are providing ampersand, it is pointing to the address of that ith index. And here A of I is pointing to the element which is present inside the ith index. Okay, so now just let us see how this iteration happens. So the first value of I is 0. So what happens? 0 is less than 5. The condition is true. So printf the value is, the output will be the value is percentage D. So what will come here? It will the value of A of 0. What is present in the 0th index of array A? It is 10. So the value is 10 in the first statement. Okay, and when the iteration comes here again, the value of I is incremented by 1 and I becomes 1. So 1 is less than 5. The condition is true. So it enters into the for loop. So what will be printed? Printf the value is A of I. And what is the value of I here? I is 1. That means A of 1. You have to print the value which is present at the ith index of the array A. That is A of 1. So what is present here? It is 20. So the value is 20. So likewise all the statements get printed and you can access all the elements. You can print all the elements present in the array A. So hope this is clear to all of you. In this session I have taken what is an array, why you use array instead of variable, what is the drawback of variable, and what is the advantage of an array, and how array is been declared locally as well as globally, and how you are going to read element into the array and how you are going to take element from the array. That means how to print element from the array. So these are the different values, things I have discussed here, plus the actual memory allocations that happens when you are declaring an array. Okay, so hope this is clear to all of you. Do watch my video for next details of arrays. I will be explaining other programs related to array in my next videos. Thank you for watching. Do subscribe my channel, like and comment also. Thank you.